All right, we're gonna try to solve this crunchy majigger. The cotangent of x times the cosine squared of x equals 2 cotangent of x. And the method that we're gonna solve this is by, as you can see by our title here, is factoring. So what we need to do first, before we even start factoring anything right now, because we can't really factor anything as is, we see it. Let's go ahead and write or rewrite everything so it's on the left-hand side. So I'm just going to put this 2 cotangent, and I'm going to put it on the left-hand side. All right. So it's cotangent of x times cosine squared of x minus 2 cotangent of x. All right. So all I've done is I just rewrote this guy on the left-hand side of our equation. Now we can factor out the GCF. We have a cotangent here with this monomial, and we have a cotangent right here. So cotangent, cotangent, I'm going to take that guy out. So cotangent times what gives me back this? Well, it's going to give me cosine squared of x. And cotangent times -2 will give me back -2 cotangent of x equals 0. And now we're just going to use what we learned back in Algebra 1, and that is if I know that a times b equals 0, then I know that either a equals 0 or b equals 0, correct? If I know that a product of two things is 0, either one of them must be 0. So I could set my first factor equal to 0 and set my second factor equal to 0, and then I solve for x. So we'll set cotangent of x equals 0, and we'll set cosine of x minus 2 equals 0. So let's start with the first one over here. Cotangent of what equals 0? Well, that's the same thing as saying the tangents of what equals, well, if I flip 0, then that means 0 would be in the denominator, which is a big no-no. No! So I want to know tangent of what is undefined. Okay, but make sure that we're within the period of a cotangent. And if you remember what the cotangent graph looks like, one period of the cotangent graph is between 0 and pi. So tangent of what is undefined between 0 and pi? Well, there's only one value there, and that's going to be at pi over 2. Okay, so if you plug in pi over 2 right here, you're going to get 0. All right, so there's 1 right there. Oh, but also the period of cotangent is pi, so we got to tack on our plus pi n, where n is within the integers. Okay, we always got to do that. You look at the function that we're dealing with, and whatever the period is, then that's what you tack on there. All right, so let's take this guy over here now. I'm going to add 2. So cosine squared of x equals 2. And I'm going to take the radical of both sides, which means that we will need to introduce the plus or minus. So cosine of x equals plus or minus radical 2. All right, so the cosine of what is plus or minus radical 2? Well, if you think about it, nothing. Doesn't the cosine graph, sorry that's so crooked there, but it starts up here, goes down, then up, right? What's the highest that our graph goes? It goes up to 1, right? And what's the lowest that it goes? -1. So radical 2 is like, approximately like 1.4 or something like that. It's not possible to say cosine of something is bigger than 1. It's not possible. So that's how I know there is no value right here. You could even search all day long also on the unit circle, but I'm just trying to go through it or explain this to you through a different approach. Knowing what the cosine graph looks like, there is no x value that if I plug in, my y value is going to be radical 2. It never gets that big. The highest and the lowest a cosine graph gets is 1 and -1. So there's no values right here. We're just going to say nothing. So really the only answer to this entire problem is just this. Pi over 2 plus pi n, where n is within the integers.